Imaginary, because they had what in them? I. Okay. And then the fundamental theorem of algebra, which you already really know, you just don't know its name. So I'm going to start with the fundamental theorem of algebra. I'm going to abbreviate it so we don't have to write it out again as FTA. I'm going to just jot down a couple things at first, just to either refresh your memory or remind you of before we solve things today. The first one is this. The fundamental theorem of algebra tells us how many zeros a polynomial has. How can I tell? The degree, right? So all that says is a polynomial of degree n, as long as n is greater than 0, has n complex zeros. And I'm going to also write some may be repeated. Some may be repeated. What I mean by being repeated is this. If I factored something and it factored into x minus 2 to the third, what 0 would have to be on that polynomial? 2. And actually, 3 of those zeros, let's say it was a degree 5 polynomial, that means 3 of them are 2. So how many would be left then? 2. Okay. So by repeated, that means that sometimes if they have multiplicity, that counts towards that number of zeros. That's all that means. Also, we just learned, like a quadratic, what's the degree of a quadratic? 2. That has, because it's degree 2, without even looking at it, I know it has 2 complex zeros. Complex can be real or imaginary. And then if I asked further how many were real, none were they? Okay, so if I ask how many complex zeros it has, don't look at the graph, look at the degree. If I ask how many are real, then you look at the graph to see. Okay. Now they remembered this in first hour, so I'm going to assume you do too. If we have imaginaries, so I'm going to write complex conjugate zeros. If you know one of the imaginary zeros, so if I said x equals a plus bi is a 0 of a polynomial. Can anybody remember? What else can you tell me? If I said a plus bi is a 0 of a polynomial, it's an imaginary one. Good memory, Abby. What was it? Then its complex conjugate also has to be, so a minus bi is a 0. And I'm going to give you a heads up, a warning. Sometimes I'm only going to tell you one of them, and you're going to need to know you need to write down the other one. Okay. Good. So I always say imaginary roots always come in pairs. That's how I say that. Okay. So good. So far we've remembered some things, but maybe you didn't, so that's good reminders. And then this is something I don't think you spent some time on it, but you might not know the vocab. So today we're going to spend some time factoring and making polynomials. So factors of a polynomial factors of a polynomial with real coefficients. Oh man. Yeah. Factors of a polynomial with real coefficients. Okay. What I want to write about this is that every single polynomial there exists, okay, as long as it has real coefficients, meaning if I would write it out before I factored it, as long as the numbers are real, so they have no i's in them, what you're going to be able to do today is they can be factored into linear factors and an irreducible quadratic factor. Okay. So, if I have polynomial with real coefficients, they can be factored into linear factors and an irreducible quadratic factor. Now, you might not know what an irreducible, I don't know if you know what that means. Do you know what that means? No? Yes? Maybe? So, the one we did on the board today, in the opener, could you have factored that into real numbers? No. That, when you cannot factor it into real numbers or the answers are not real, that's when it's an irreducible quadratic. So an irreducible quadratic just means that it doesn't have real zeros. Okay. And so really what I just wanted to make sure I did here was spend some time just refreshing those things, just so I didn't launch right into this example and assume that you remembered them. I don't know that you remembered this from last year, but it sounds like some of you remember this and most of you remember that. Okay. All right. Good. So